So the next unit we're going to do is what's called solving a system of equations. Long story short, a system of equations is one or more equation that you solve at the same time. Now, the reason we have to have one or more equation is because we're going to have more than one variable in our equation that we're trying to solve. That being said, if I were to give you, say, one equation, like we've been working with, just a linear equation, something like this, you can't solve that. You might be able to rearrange the pieces and get x equals or y equals, but you don't get a definitive single answer. You can't solve a multivariable equation if there's only one equation. So that kind of ushers in what's called a system of equations. You need to have the same number of equations to work with that you have variables that you're trying to solve for. So my equations here, this guy, 5x minus 9y equals negative 17. This pair of equations, I can show you how to solve that where you get the single answer for both equations. Same thing here, if you've got two that are in slope-intercept form, basically it comes down to the more variables you have, the more equations you're going to have to work with. Now, if this goes well, we might eventually get to the point where we're solving a three-variable system, and if you notice, there's three equations for that. Now, there's a bunch of different ways you can solve these. There's actually three different ways you can solve a system of equations, and we're going to kind of go through them one at a time as we proceed through this unit. And that is going to depend on how the equations are presented to you. So today we're going to solve these. If you didn't notice, we're going to solve these by graphing, which means the equations are going to be presented to you in a manner that lends them to being graphed. Namely, your equations will be given to you in slope-intercept form. So hopefully you remember from the last couple of units how to graph these relatively easily. You've got a y, whoops, I jumped ahead there. You've got a y-intercept at the end to start at. So I'm going to start this guy at negative 5. And I've got a slope of negative 4. That tells me to count down 4 units. And since it was a fraction, negative 4 over 1, I move 1 unit to the right. So I'm going to do that a couple of times here to get more points to graph. But you get a nice, wow, I messed that guy up. A nice straight line here that goes through all the points that you graphed. Dang it. My mouse isn't liking me here. There we go. Okay, so that's my first equation graphed. When I do the second one, starting at positive 5, and then I'm going to count down 2 units, 3 to the right, down 2 units, 3 to the right. And when I graph that line, now, this is not a real precise way to do this unless you're using either graphing software, which you don't have access to, or a graphing calculator, which you don't have access to. So we're looking for a best guess here. Okay, here's where my lines cross. Now, I will freely admit that this is not a very, very accurate way to do this. I seem to be way better on this if I use pencil and paper than I am graphing on a tablet like this. The solution to this guy is actually here, negative 3, 7. And I'll show you how I got that a little bit later. But for now, what I'm looking for is for you guys to graph these and give me your best guess as to what you think the solution is. So when we graphed it, it looks like I graphed negative 4, 8. Right, that was the first point that I had there where my lines crossed, and I'm saying that the solution is actually negative 3, 7. Okay, so I was just off a little bit. That doesn't seem like that big of a deal to me as far as the graphing goes. I'm sure other teachers would disagree. When you go to solve these algebraically, when you're actually working with the equations instead of the graphs, it's like the difference between a hand grenade and a sniper rifle. I mean, the graphing is kind of a big approach. The solving it by using the actual equations is very precise. You'll get it dead on 100% of the time. All right, so the second one here, I'm going to do the same thing. I'm going to graph starting at negative 7, and then 4 up, 7 to the right. So I've got my line here. And then my second equation starting at positive 3, down 6, 7 to the right. Now that one, if you notice, the point that I just graphed on my second equation was the same as the second point that I graphed on the first equation. So I know that one's 100% dead on. So my solution in this guy is 7, negative 3. And I think what we're going to do is I want you guys to graph these today and give me what you think the best answer is. You know, like I said, if you get it dead on, great, like the second one. But if you get pretty close on the first one, we'll let it go today. And tomorrow I'm going to show you how to verify or check your answers to see if you are right or if you are wrong. After tomorrow, we probably won't even look at these as far as a graph goes anymore. We'll do it all pencil and paper and actually working it out using some equation solving skills.